Hello students, so welcome to the lecture number 6 of chapter 7. So up to this we have completed two congruency of triangle. The first congruency of triangle is SAS congruency. So it means if any two sides and the included angle of two triangles, of two corresponding triangles are equal, then they will be congruent. This is SAS congruency, and this is also an axiom. That is axiom number 7.1. Okay, we have discussed it, and the next congruency that we have discussed is equal to or is ASA, angle side angle congruency. It means if any two angles and the included side of one triangle is equal to the another two angle and the included side of another triangle, then that two triangle will become congruent, and this is a theorem, that is theorem number 7.1, right? And we have also completed 1 to 2 questions based on this axiom and based on this theorem. Okay, so today in this lecture we are going to solve some questions from the exercise 7.1. Understood? And all the questions from this exercise based on only this two congruency. Okay, so without wasting time, let us start the first question. So we have to first understand the statement, then we have to draw the figure if necessary, then we will solve. Okay, so let's start reading. The first question is in quadrilateral ACBD. Since here is a figure and the name of the quadrilateral is ACBD. Okay, always whenever you are counting a quadrilateral or any geometrical figure, always write it in either cyclic order or in anti-cyclic order. Okay, this direction is known as cyclic order and this direction is known as anti-cyclic order. Okay, do not call it haphazardly. Don't call this as A, B, C, D quadrilateral. No, it is incorrect. You have to name them cyclic. Okay. So the question is, here is a figure ACBD, and in this figure AC is equal to AD. Okay, it is given that AC is equal to AD. This side is equal to this side. Understood? And AB bisect angle A. So this is the angle A. Now this angle is bisected by AB. That means this is the angle bisector. So what is an angle bisector? An angle bisector is a line which bisects an angle into two equal halves. It means this angle is equal to this angle. Understood? And from this data you have to show that the triangle ABC is congruent to the triangle, sorry, I have written wrong. The triangle ABC is congruent to the triangle ABD. Okay, so this has to be proved. And the second thing is, we have to find the relationship between BC and BD. BC and BD. Okay, now you understand the question. So let us write what is given in this statement. So it is given that AC is equal to AD, okay, and it is given AB is the angle bisector. AB is the angle bisector. So can we write this angle is equal to this angle? Yes, we can write. So we can write angle CAB is equal to angle DAB. It is clear. So this is the data. Now we have to prove that these two triangles are congruent by comparing them. So you can write between triangle ABC and triangle ABD, what are equal? Since AC in this triangle, this side AC is equal to in this triangle this side AD. Okay, we can write AC is equal to AD. Why? Because this is given. Okay. Second, this angle of this triangle is equal to this angle. Why? Because this is the angle bisector, so divide this angle into two equal halves. If it is 50 degree, then it is also 50 degree. Okay, so you can write that this angle CAB is equal to angle DAB. Why? Because AB is angle bisector of angle A. Understood? Now the third point is AB is a side of this triangle, isn't it? Yes, true, it is true. And that AB is also a side of this triangle ABD. So AB is a common side to both the triangle. So AB is equal to AB. Why? Because they are common side. Understood? So what do we get here? We get that in this triangle, this side is equal to this side. And this is the common side to this triangle, and this is the included angle, and this angle is equal to this angle. So by SAS congruency, we can write that the triangle ABC is congruent to the triangle ABD, and now it is proved. Do you understand? Okay, it is now proved by SAS congruency. It is very easy. Okay, this is the proof of the first statement. Now coming to the second statement, we have to show the relationship between BC and BD. How? Since we have already proved that this triangle is congruent to this triangle. Since triangle ABC is congruent to the triangle ABD. Now remind the axiom 7.2, CPCT. If two triangles are congruent, then their sides are equal, corresponding sides are equal, corresponding angles are equal. Okay? Since this triangle is equal to this triangle, then can we write that this side BC is equal to this side BD? Yes, you can write. Why? Because they are CPCT. Or you can write axiom 7.2. Now this is the relationship between BC and BD. Hence you can write that BC is equal to BD. Understood? Now let us solve the question number 2 of that exercise. Okay. So here it is given that ABCD is a quadrilateral. So it is a quadrilateral having the vertex AB, C and D. Now in this quadrilateral it is given that AD is equal to BC. AD means this distance is equal to BC, this distance. Clear? And the angle DAB, which angle? Angle DAB means this angle. Okay, this angle is equal to CBA. CBA, which angle? This angle. Okay, so it is given that this angle is equal to this angle and this side is equal to this side, and from this data you have to prove 3 statements. Okay, so first statement is triangle ABD. ABD. Look at this triangle. This triangle ABD. This triangle is congruent to the triangle BAC. BAC. Okay, again I am telling you, this triangle is congruent to this triangle. We have to prove this. And the second statement is BD is equal to AC. BD means this distance, BD. Okay, so BD is equal to AC. Understood? Third statement is angle ABD. Which angle? ABD. Which angle? ABD means this angle, this small angle, not the total angle, this small angle is equal to BAC. BAC, that means this small angle. Okay, so this 3 statements need to be proved. So let us first prove for the first statement. So for proof 1 or I. So here we have to prove that this triangle is congruent to this triangle. In order to do this, we have to compare these two triangles and find out which parts are equal among these two triangles. So between triangle ABD and triangle BAC, let me draw it in another plane. ABD, okay, like this, this ABD. This is the first triangle. And BAC, okay. So BA, another triangle C. Forget about CD. Forget about it. Only consider which triangle? This triangle. This is the first triangle, and this triangle. And it is given that this distance is equal to this distance. Clear? And in this triangle, this angle is equal to, in this triangle, this angle is given already. Okay? So let us find and identify which parts, which corresponding parts among these two triangles are equal. First condition is that you can see in this triangle, or you can say in this triangle, this side is equal to, in this triangle, this side. Yes or no? Yes, AD is equal to BC, it is given. So you can write that AD is equal to BC. Why? Because it is given. Okay. Next thing. In this triangles, if we consider in this triangle, this angle is equal to, in this triangles, this angle. Okay. So this angle of this triangle is equal to this angle of this triangle. So you can write that this angle is equal to this angle. So you can write that the angle DAB is equal to the angle this, okay, CBA, this angle. Clear na? Okay, this is the second statement, second similarity. Next similarity is that if we consider this triangle, which triangle? ADB, then this is the side of this triangle. Yes or no? Tell me first. Yes. So we can write that AB is a side of which triangle? ABD triangle. It is clear? Next, if we consider this triangle, which triangle? See, which triangle? BAC. Then this is also a side of this triangle. So AB is also a side of BAC triangle. So what we find? We find that AB is a common side. AB is a common side to this triangle, to both the triangle. Okay, so we can write AB is equal to AB, common side. I have forgotten to write this. This is also given. Understood? So finally we find that between this triangle and this triangle, this side is equal to, in this triangle, this side, and this included angle of this triangle is equal to the included angle of this triangle. Okay, careful about finding the included angle. Okay, so this included angle is equal to this included angle. So by side angle, these two triangles will be congruent. So you can write that the triangle ABD is congruent to the triangle BAC by SAS congruency. It is clear now? It has been proved for the first statement. Okay, this is the proof for the first statement. It is also a very easy question, right? Next, coming to the second statement, we have to prove that BD is equal to SC. This BD is equal to SC. Okay, let us prove here. Okay, what we have proved here? We have proved that the triangle ABD is congruent to the triangle BAC. Okay, let us identify those four triangles. This is the ABD, this is the BAC. Now, see, if we consider this triangle, then this is a side of this triangle. Yes or no? Yes. So BD is a side of which triangle? Triangle ABD. It is clear? And if we consider this triangle, then AC is a side of this triangle. Which triangle? ABC triangle, or you can say BAC triangle. Okay? So AC is also a side of BAC triangle. Okay? And we have proved that these two triangles are congruent. And now remind the axiom 7.2. According to axiom 7.2, if two triangles are congruent, then their sides must be equal. Their angles must be equal. So can we write that this side, that means BD of this triangle is equal to this side, means AC of this triangle, because AC is a side of this triangle and BD is a side of this triangle. So can we write it? Yes, we can write it. Why? By simplicity. And this is the proof of second statement. Proved 2. This is proved 1. Okay? Next proof. See, we have to prove ABD angle is equal to BAC angle. Right? So let us first identify those two angles. ABD and BAC. ABD angle, ABD, this angle. If we consider this triangle, then this is an angle of this triangle or not? Yes. So can we write that ABD angle is an angle of this triangle? Yes or no? Tell me. Yes, it is true. Similarly, if we consider this triangle, then can we say this is an angle of this triangle, this side, this angle? Yes, this angle is BAC. So BAC is also a angle of the triangle BAC. Understood? But we have proved that these two triangles are congruent. And according to the axiom 7.2, if two triangles are congruent, then their angles must be equal. So can we write that this angle is equal to this angle? Yes, we can write. So we can write ABD is equal to BAC. Okay? Do not write this. I write this only to make you understand. So finally we have proved that ABD is equal to BAC. Why? Simplicity. Corresponding parts of congruent triangle. And this is the proof of third statement. See this, how easy? If you understand it clearly, then it is easy to you. If you don't understand it clearly, don't going into the depth of this theory, the depth of this concept, then you will find that this chapter is very tough for you. Okay?